On behalf of 24HourAnswers.com, I welcome you to today's lesson. In this video, we're going to look at two examples of using the quotient rule to find the derivative of a function. And we have two examples here. This first one, I want to show you two different ways that we can find the derivative. One is doing a little bit of algebra first, and then we're going to find the derivative, and then we'll come back and actually use what's called the quotient rule. You got to know the quotient rule in order to master differentiation, because the algebra shortcut I'm going to do here first, we cannot do that over here. And another thing, very important, when you find a derivative of something that is a quotient, notice we are dividing two things here and dividing two things here. You cannot take the derivative of the top divided by the derivative of the bottom. Quotient rule does not work like that. So the first way we're going to do this example here is I'm just going to rewrite h of x by dividing each piece by x. Take the 3x squared, divide by x, we get 3x. All I'm doing there is subtracting exponents. Take the negative 5x divided by x, the x's cancel out, so we have minus 5. And then taking the negative 1 divided by x, we can write that as minus 1x to the negative 1 power. We can shoot that up here. So really what I did here is I divided each term by that x. And now we can find the derivative by simply doing our basic differentiation rules. H prime, the derivative of 3x is 3. The derivative of negative 5, that's a constant, so that is 0. And then the derivative of this one using our power rule, negative 1 times that negative 1 gives us plus 1, x to the negative 2. Remember, you have to subtract 1 from the exponent, so be careful there. Therefore, our derivative, cleaning it up a little bit, we get 3 plus x to the negative 2. Now we can rearrange this and rewrite it. We could say that h prime of x is equal to 3 plus 1 over x squared. And if we get a common denominator here, if I come in here and stick a x squared at the bottom of this one, as long as I stick it up here at the top and make it look a little something like this, 3x squared plus 1 all over x squared, that's totally fine. And this is the way I'm going to leave it, and you'll see why. We're going to come and do the quotient rule with this problem now, and we're going to get the same answer that looks something like that. But again, all we really did here was a little bit of algebra. We divided everything by x. We did our basic differentiation rules. Then I just rewrote it using a positive exponent, and we got common denominators. We'll come and do number 2 in a second, but I want to show you another way of doing this. We have really a quotient of two functions. We got this function up top, this trinomial, and then we have this function at the bottom, this x. Let's call this top function f, and let's call this bottom function g. A way that we can find a derivative using the quotient rule for differentiation is, I'm going to call this h prime of x is equal to, we take our bottom function, we multiply it by the derivative of the top, so that's our bottom function times the derivative of the top, g f prime. Then we subtract f times g prime. So really what we're doing here is we're leaving g alone. We're multiplying by the derivative of our top function, subtract the top function times the derivative of our bottom function. We're kind of doing a switch here. And be careful with the order that you do these, since we are subtracting. And then we want to divide all of this by the bottom function squared. And a way that we can also remember this in the order, making sure we don't mess up with our minus, look at what I have here. Low d high minus high d low all over low low. Well, really what we're doing here is this. We're taking our low function, the g, d high, the derivative of our top. So there's our low d high, that's the derivative of our top, minus the high function, f, the top function, d low, that's the derivative of our bottom, all over low low. So all over low low, or low squared. We're taking the low function times the low function. That's what the low low stands for. So the d high, d low, that means your derivative of your high function, your top function. D low, that's the derivative of your lower function. And in this case, we call them f and g. So let's find the derivative using the quotient rule. H prime of x equals low, so we leave our x alone, d high, that's our f prime, so the derivative of this is going to be 6x minus 5 And all I did there was take the derivative of this top piece, 6x minus 5, and that derivative there of that constant becomes 0, minus high d low. So now we leave the top function alone, 3x squared minus 5x minus 1. D low, I'm right here, the d low, the derivative of x is simply 1. And then we put this all over low, which is going to be all over the bottom squared, so all over x squared. Now, if we simplify this down, we should get this right here. So doing a little bit of algebra, we get 6x squared up top, distributing the x to here, and now distributing there, minus 5x. This 1 times this stuff is not going to change it, but watch out for that minus. So we have minus 3x squared plus 5x and a plus 1. Be careful with your distributive property. All of this is over x squared. And now cleaning this up a little bit more, our 5x's cancel out. 6x squared minus 3x squared is 3x squared plus the 1 all over x squared. And as you can see, we are getting the exact same answer when we do the quotient rule. Now, again, it may not have looked like this had we not gone through these extra steps of getting common denominators, but I did want to do that because I wanted to show you we would get the exact same answer using what we call the quotient rule. Now for number 2, the way we're going to approach this, we can't do any algebra to simplify this, so we're going to go straight to our derivative, and since we have a quotient of 2 pieces, you know, we got our high, if you want to call it high, and we have our low down here. I know I called them F and G, but this right here may help you remember the quotient rule better. So let's take our low, e to the t, d high, the derivative of sine is cosine, so we got cosine of t, and yes, we are multiplying these together. So there's our low d high minus high, let's leave the sine alone, so sine of t, d low, the derivative of e to the t is e to the t, so we're going to multiply by that, and this is all over low. So e to the t times e to the t is going to be e to the 2t. All I'm doing there is really just taking e to the t times e to the t, and our properties of exponents means here that we can add those two together. So that's where I'm really getting that 2t from. Now from here we can do a little bit of simplifying. We got this chunk here and this chunk here that we can factor a e to the t out of. When we factor e to the t out of this, we are left up top with cosine of t minus the sine of t, and then this is all over e to the 2t. And just like up here where I added my exponents because we had the same bases and we got the 2t, we can actually subtract exponents here since we had the same bases. That's a property of dealing with exponents. When you are dividing like bases, you subtract the exponents. And since I have 2 t's down here and 1 t up here, we can simplify this to be the following. Cosine of t minus sine of t all over e to the t. And the reason why it's just a e to the 1t now, because I took this one away, so really I'm taking away one of those t's. That's how we're left with that t right there. And there you have it, 2 examples of doing the quotient rule. The first one, if you skipped over it, go back and check that out. We looked at it 2 different ways, using a little bit of algebra and then actually using the quotient rule. And then the second one here, the only way we can do this particular derivative is to do the quotient rule. You can either do the gf prime minus fg prime over g squared, or you can take this little way to help you remember it, low d high minus high d low all over low. Either way works. And that's it for this video. I hope it helped. Be sure to check out our YouTube channel for more videos. Links to our social media are in the description below.